Welcome to the bridge course on CS303 System Software. The aim of the bridge course is connecting your previous knowledge with the new subject. Where the prerequisites are computer architecture and microprocessor. What is system software? It's an interface between the programmer or user and the hardware of the system. This sort of software will help the programmer or user to do some work in the system. Here you have to learn editor, assembler, linker, loader and macro preprocessor. You are learning all these topics based on a hypothetical machine named SIC and SIC-XC. Your textbook is Leland L. Buck. The aim of this course is learn the design and analysis of system softwares. We will be starting with an introduction to all the system software, then directly moving to the SIC and SIC-XC. And all the topics are based on SIC and SIC-XC assembly language program. So to write an assembly language program, you should know the architecture of the machine, its memory management, then assembler directives, etc. etc. Okay, let us start with a discussion of an 8086 assembly language program, which will add two numbers. The first number is byte, let it be some 20. The second number defined by some 10. We are expecting the sum in the variable sum. That is the end of data area of the program. This assembly language of A086, it is case insensitive. For our readability, we are using uppercase and lowercase letters. Then the code segments start the code area of the program. Segment is an assembler directive which tells the beginning of a segment, and NC is another assembler directive which will tell the end of that segment. Assume is another assembler directive which we are directing the assembler that There is a segment named my code is there in the program, and it should be used as the code segment of the program. And data segment of this program is a segment named my data. Here the executable instructions start, and here we have initialized the data segment ratio of 8086. It cannot be initialized directly, so we have moved the address of the data segment to AX register, then AX register to DS register. Then we are taking the first number in DL register. 8086 use 16-bit registers. You can treat them as 2 8-bit registers. So here we are moving the first number to the lower 8 portion of the BX register. We are taking the second number in DL register, lower 8 portion of DX register. Then we are adding BL and DL. So it will be stored in DL. Your result in DL register. Now we are moving the content of BL register to the variable sum. Next, let us terminate this program. Move AL comma 00. Is the return code. Move AH comma 4CH is the interrupt, DOS interrupt to terminate the program. Then INT 200 the DOS interrupt call. So this is the end of my code. Then I'm marking the physical end of the program. Along with I should give the label where the program execution should start. Let's save this program. Its name is my program rotation. Okay, let us check the folder. My pgm.asm, it is there. Next, I have to use an system software named assembler, which will translate the assembly language program to an object code. Okay, for this I should use a DOS box because my Windows is 64-bit and the software TASM is not compatible with 64-bit Windows, so I should use a DOS box. /TASM TASM.exe is a program to which I am passing my assembly language program, my program.asm. It's translated without an error. Let us check the content of the directory. See, my program.asm. Another file is found, my program.obj. The next, I have to use another system software named linker. I will be passing this obj file to this linker program. Linker is nothing but which will link the external libraries with your program and generate the machine code. See in your C program, the functions printf and scanf, you are not writing that. That is available in the library stdio.h. So we will be linking this library with your program. It is linked without an error. Let us check the folder. See extra files are there. My pgm.exe, then my pgm.map. These are the files formed by the linker program. Here this my pgm.exe is the executable one. Under those there are three type of files which are called the executable. First one .com file, then .exe, then .bat. These are called executable file types. I can give this name here, my pgm.exe or simply my pgm. It will work. Okay. Here an interpreter is working. If I type some ABC, I will be getting some illegal command. So first the command interpreter will check whether such a command is available. If it is not, it will go for an executable file in the order com, exe and bat. So let us what the output of this program. How can we see the output? So we need another system software named debugger. Here nothing displayed on the screen because we have not instructed the program to print something on the screen. Okay, let us run the debugger software. To which I will be passing my exe file. I will be getting this screen. By pressing F7, I can run the program step by step. You please note the changes in registers. Now AX register is 0000. I execute the first statement, it will be changed to 44EAD. Then initializing the DS register, then moving the first data to BL register. See now the BL part of BX register is 0000. When I execute this, it is loaded with the value 14. 14 is nothing but 16 plus 4, it is 20. It is in hexadecimal. Then to the BL register I am taking the next data, that is 0A, that is 10. Then adding BL comma DL, and result will be stored in BL register. See the change, it will be updated to 10 plus 20, it is 30, 13 is 16 plus 14, so it is 1E. So BL part will be updated to 1E now. Okay, it is updated to 1E. Next, we are moving the DL content to the variable sum. Okay, before that, let us check our data, our data segment. See, it is first data is 20, it is 1 4, and our second data is 10 0 a, and this is the space for the variable sum. Now it is 0 0. When we execute that instruction, it will be updated. Okay, we are moving the DL content to the variable sum. Let us check the dump again. See, 1 is stored there. Now we are terminating the program. And the program is over. Hitting the awesome debugger. We are able to write this assembly language program because we know the architecture of 8086, we know its registers, we know its memory management, we know assembler directives, etc. etc. So here you have to learn the architecture of SIC and SICXE. First we learn the architecture of SIC, then we will try some simple programs of this SIC, and we will proceed with its uh, different functions of assembler, then this machine dependent features and independent features. And remember, all these are based on SIC and SICXE programs. So you should be able to write SIC and SICXE programs. So in the second unit, you will be learning all this machine dependent and independent assembler features. Then next you will be moving to the implementation 2 pass, 1 pass assemblers. Then you are learning about the concept of linkers and loaders. Then the microprocessor. And last we will be discussing device driver and some text editor and debugger. Okay, let us move to the architecture of SIC. SIC is simplified instructional computer. You just go through the architecture. Its memory consists of 8-bit bytes and its word length is 24-bit, that is 3 bytes. And its physical memory will be 2 raised to 15 bytes. Then the registers available with this SIC. First one, the accumulator. The mnemonic is IA. Then the index register is related to the addressing modes. Then linkage editor. Then program counter. And the status mode. Next comes the instruction format. Okay, we will see it later. Then the addressing modes. Addressing modes are available, direct and indirect. Then the instruction set. Oh, this much. load and store, then arithmetic instruction, then comparison of instructions are available, SIC. And coming to the instruction format, while doing the 8086 program, you have written the assembly language program, then translated it, linked it, and run it. But you didn't bother about the machine language program. Okay, but this but with this SIC and SICXE, you are manually doing the generation of machine code. Okay, once the mnemonic end of code is given, you should be able to generate the corresponding machine code. Can we watch the machine code of the 8086 program we have written? Let us check the machine language program generated. You can see my program, my pgm.exe, it was executable. And when you type my pgm, my program here, once it is found it is an executable file, the loader will load this program for execution to the primary memory. Okay, to list the machine language instructions, you should do it at the time of translation. Awesome slash awesome.exe with the switch slash l, and your program my pgm.asm. Okay, let us see what is created newly there. You can see a file named lst is created. Okay, let us check its content. I think it is this one. Here you can see the machine code corresponding to your assembly language statements. So it is generated by the translator, but in the case of SIC you have to do this task. For that purpose you are learning this instruction formats. Next, let us check how can we write an SIC program to add two numbers. Okay, we know the mnemonics. There are arithmetic instructions, add, sub, mul, div, etc. there. Then for loading and storing instructions available. Okay. The next you want to know how to declare the data. See what we have done with 8086. See the data segment of the program. We can see num1 or db. db means defined bytes. Its value is 20. Then num2 is a byte variable, value is 10, and here sum also a byte variable whose value is not initialized. Okay, next let us see what is the SIC program. This is the XIC program to add two numbers. See, num1, num2 are the numbers. LDA num1 means loading the first number to the accumulator, and num2 means add num2 with the accumulator and store the result in accumulator. STA means show the content of accumulator to the variable sum, and see the data declaration. Num1 word 20 means this is a word constant. The word length is 24 bit. The registers are 24 bit. There's a word constant, and num2 also a word constant, value is 10, and here it is a word variable which will use a single word. This is the data declaration, and this is the program. So it is very simple to write. So for this you should understand the mnemonics, then the assembler directives, etc., etc. And we'll be discussing more SIC and SIC programs in the coming classes. And remember, all the features and all the topics are explained based on some SIC or SIC program. So you should be able to write, understand, analyze the SIC programs. Okay, we will continue in the next class.